Hello. Welcome to the last presentation for today. I hope you feel well after that amount of knowledge for today. Okay, still some power. As it was introduced, I have at least 8 years of experience. I work in the telecommunication industry now in the IT for KMD more than 3 years, I believe so. So quite a long time still from the beginning as the DevOps engineer, now the architect of also the systems. So the agenda for today. We will talk about the cloud project overview, how we see in our company the majority of the projects, what are the challenges. Then I would like to talk about the building blocks, what we developed inside the KMD to help us in our daily work, as well as example setup of how we set up all the projects, and what is the workflow that we are currently working on. And then some the future, what we think about, but still 24 hours is not enough time to develop everything. So next year maybe we'll develop something more. So the overview. As you may know, we work mostly on Azure, so we're developing cloud applications at Azure, and it consists of several objects inside the Azure, and we are dealing with the applications. So basically all images are generated with the AI, so I'm not drawing them also. So this is how AI sees the developer developing an application. So and basically it's rather simple. Developers developing some application and they would like to put something on the cloud. So yeah, something like that. It's relatively simple, easy peasy. As you also may notice, even from today's poll, most of our applications like Kubernetes. So we also like Kubernetes, and Azure is the Azure Kubernetes service, and is the application platform. And also, if we have some applications, we have some secrets data. So we have the Azure Key Vault to store credentials and the password. Also, we need some gateway to our cluster, because the Kubernetes clusters, usually we have the private, so no external access at all. So we have the Azure Application Gateway, which provides us external access. So also we need to connect somehow so we create external network to connect the Kubernetes services with the load balancer. Okay, so we have the, let's say, public part. Also, for the supporting services, we need some probably internal workload. And in this internal workload, we can have some virtual machines to, I don't know, store some databases, so store some services, bastions, jump hosts, you name it. So anything that we require in the project. Also, we can use the virtual machine scale set for different purposes. For example, we have some automation, so the pipeline, and we need to run somewhere. So usually it's good to have, for example, virtual machine scale set, because we can scale from 0 to 100 if that's the case. Also, maybe in our project, we're requiring some storage accounts. So, okay, no problem, we can add this. And for example, our applications of developers require some MySQL. So, okay, Azure also have some MySQL, so we can put it that. And all of those are in our virtual network. So basically, that's our infrastructure. So we have that. Then we would like to install some applications. Besides the developer's application, we would like to install some helper applications, monitoring applications that we are having in projects. Grafana, Loki, to have some insight what is inside the cluster and basically feel better with having that. And of course, our application. So more or less, after let's say 2 weeks of creating all this stuff with the developers, we have our environment and we can put it to the internet. So yeah, relatively easy. We have all the infrastructure. We are ready to go. And maybe after some time, developers said, okay, we need additional storage account. No problem, we can add it. And after, let's say, initial testing for 1 week, additional resources were created because the developers required something more. So after, let's say, a month, we have this particular infrastructure. So it's complicated? No, yes. It depends, okay. So let's simplify because it's too much text, so I can simplify with the text. So we have something like AKS, VNet, VM, storage, okay. So that's our project, let's say alpha. So we have the project alpha, we have our dev environment, we perform some testing, and after some time we have additional environment for testing purposes because we would like to distinguish traffic from the development and application that will go into production sometimes. So we reconfigure something, we have some additional configuration, maybe some different databases, different sizes, different configuration, different resiliency, etc. Okay, we still have two environments, that's okay. And now, after some time, we have the production. Yes. Everything the same, more or less. And after some time, let's say another project came to our team and, hey, you do pretty good job. How about create an additional project for us? So basically you have the all pieces. Let's create it so we get everything we knew from the first project, create in the different project. Maybe the difference will be that instead of the MySQL, the second project would like to have the Postgres. So we can configure the Postgres, no problem. And now we have two projects with 4 different environments split between them. So okay, still okay-ish. And let's say I'm configuring some of the project, for example, in the project beta. And then after some time, I'm creating the test environment. And in the meantime, my colleagues created a playground for the first project and reconfigure something because the developers wanted to introduce some new changes. And then he asked me to, hey, maybe let's reconfigure something on the dev or test. And I wonder what is the configuration. And I'm trying to look into this playground project, and basically most of the environments I created from the scratch. The playground was created from the scratch, but different naming. So I need to some time to recognize what is where. So after 2 hours, I know what exactly is configured. So I'm ready to go. And yeah, so I reconfigured. Everything is fine. Then our second project is in production, and they wanted to introduce some additional changes to the infrastructure. So now we have a little bit more environments at manage. And yeah, that's fine. Maybe we need to reconfigure some storages in one of the environment, but which environment, which storage, which where? Did we had some development tests, whatever. And yeah, you feel comfortable with that? Having that many environments, everything created from the scratch or using PowerShell script, that's a little bit of automation. And then let's say our team lead or manager comes in and it's asking, how's it going? And the usual answer, it's fine. Everything is fine. You can see the screen. Everything is working correctly. If so, yeah. So what are the challenges that we have in our project? So I try to identify some of them. So multiple environments with different configurations. There are some similarities, but more or less they are different because there are different project needs. So there is no rule to apply them all, one infrastructure to all, but to distinguish a little bit. Different components in every setup, manual resource configuration. So meaning, yeah, sometimes even if not ourselves, but our colleagues from the team reconfigure something and don't tell us that they reconfigured, and then we are trying to troubleshoot what happened. And after some time, oh, okay, that was the change from MySQL version this to this, for example. Multiple application version support, because all of those environments are not in the same version, especially for Kubernetes. No, it's not so easy. Fast reaction to cloud industry changes, meaning that even for the last couple of months, Microsoft introduced quite a long time ago. For example, MySQL flexible servers and the single instances that we used to have in the project will be deprecated in the future. So we need to move resources from single instances to the flexible servers. So for the majority of the project, we already did that. But for example, I saw the information that, for example, the Postgres instances will also be deprecated in the future. So probably for the projects where we have the Postgres, the similar thing needs to be considered. So yeah, little cloud things that we need to do at daily work. Kubernetes cluster monitoring and alerting. Yeah, we need to install that to know what is happening, but it's not from the scratch. So if you're creating the Kubernetes cluster, there is no inside monitoring. And different project ad hoc support. So basically, I'm right now in one project, and oh, now it's working. And maybe some colleagues requires support in another project, or he or she is going to vacations, so somebody needs to take care of, for example, for 2 weeks for the project. It's sometimes hard to jump between projects. So after creating this slide, I've looked into, let's say, my portfolio and wanted to know what projects I'm handling and what environments. So basically, I found that I'm involved into at least 4 projects with different environments, different Kubernetes versions inside those projects, and different infrastructure. So for example, in one project, we have from development to production 4 environments. For each environment, we have 2 AKS clusters. Some of them are in Azure. If somebody was on this HCI stack, also some of those are in this project. So also we are doing in cloud and on-prem. Second project, only 2 dev environments because we are still spinning up the applications. One project with 1 initial dev because we are starting that, and second project, project number 2, we have 5 environments right now from dev to production. So we have the proper testing everywhere. So at least from this one, I counted 16 AKS clusters, MySQL, Postgres databases, and some Windows and Linux-based agents. So we thought, okay, what we can do to simplify our work and to build project faster, more reliable, and to know what we have inside each of the environments. So we decided to go with some of the open source projects, and we didn't know what to decide because from my past, from the perspective I see in the past, some of the open source projects came in. There are for, let's say, 1-2 years, and after that, there is no community to support that. And basically, if we have some production systems using this open source, basically we are the maintainers, or we need to fast switch to another. And to not be in that situations here, we found out that there is a nice foundation called CNCF. I don't know if anybody heard about them. Okay. For those who don't know what this is the Cloud Native Computing Foundation is the foundation that gathers all the open source projects, builds the community of developers, sysadmins, DevOps, all who is interested in creating good software for the industry. And thanks to this community, the open source software is up to date, is reliable, it can be used by the industry. Fun fact, the first project was the Kubernetes itself. It was the first major project, so this is the foundings of this foundation. And now there is, I believe, 3 levels of graduations. So if the project is graduated, it means that it's good support, it's widely used, it's secure enough to use, and probably will not die in nearest future. So there are at least, I took this screen from yesterday, so you can see that there are a lot of graduated projects already under the CNCF foundation. Of course, there is the Kubernetes. For example, there's the Prometheus. So if you're using the Prometheus as the standard observability tool and monitoring, it's also widely adopted. And there's also one thing that I'm particularly interested is the Argo CD. So the continuous integration and develop and delivery platform that helps manage the applications inside the Kubernetes cluster. Unfortunately, Grafana is not there. As you remember, we are installing usually the Prometheus, Grafana Loki. Grafana and Grafana Loki are not part of the CNCF product under the CNCF, but I was on the conference, and usually when there is a Prometheus, there is someone also from the Grafana, so they're closely together. And yes, so we have the Kubernetes for orchestration. We see that there's Argo CD that helps us integrate and deliver applications to our platform, and we need something to build our infrastructure. And we found out that there is a nice tool called Terraform. I hope you heard about it. So it's the tool developed by, I believe it's HashiCorp, to help create resources in the cloud, both private and public nowadays, using the spatial API. And basically, you are creating a code in the Terraform language to deploy something in the cloud. So having the Kubernetes, thinking about Argo CD, and thinking about this Terraform, we tried to identify the building blocks of all our projects. So basically, we found 3. Infrastructure, monitoring apps. Those are apps that we are Steam using to drive products. And the project apps, so basically this is what developers will do. And let's say for all of those, we will create a separate Git repository to have this code inside. Especially for monitoring and for the project apps, we will use Helm pattern. I hope that if you are dealing with the Kubernetes, you are deploying your applications using the Helm chart templates, because it simplifies a lot deploying and managing the applications. And hopefully, having identified that, we can use the tools proper all these 3 areas. So for the infrastructure, we'll use the Terraform. And for the monitoring and for the project apps, we will use the Argo CD to maintain our configuration and to configure all our applications inside the cluster. So basically, thanks to that, we covered all 3 areas here. So Terraform. In Terraform, in our team, we developed some modules to represent all the things in Azure. So we create some modules to represent the SQL Server, Key Vault, AKS, Application Gateway, Storage Account, and the modules that are required by some of our projects. Just in the similar to if you are developing some applications and require some functions, you just get the libraries. So for us, those are the libraries that we can use in projects. Not all of them, some of them, but with the best practices from our perspective, how the service should be configured. Of course, each project could have its own configuration. If not, we have, let's say, best practices already there. And let's say we have still 2 projects, Project Alpha, Project Beta. So having that written in Terraform as a modules, we can create our projects. Let's say from Project Alpha, we will use those modules. And for the different project, we can use those modules that are, let's say, our standards. But this second project does not require all of them. But we have that in our portfolio. So basically, we can manage from one place and then repeat this configuration elsewhere. And for the Argo CD, we also have our applications that we have standard configuration that we can, if we don't know what to install, we install that, and then we can tweak according to the workload, according to the projects. And those should be inside the Kubernetes cluster that will be installed into the project. And the last thing is, I didn't change it. It should be project applications, so I need to fix that. But there is a very similar way. So we have the blocks of the application, so the configuration for our applications. Usually, developers' applications that are developing the project. And also, we'll put them into the Kubernetes cluster. So what is the setup that we are dealing with? We structurized the project just to have similar feeling when jumping from project to project. Because if we code the blocks in the Terraform, usually our input is the project name and the environment. So all the naming, all the conventions are the same. So no matter where you are, in which projects, usually the structure should be the same. So you should feel familiar. So we have the following structure. We have the Azure pipelines, which describes the infrastructure steps in Azure pipelines, Azure DevOps, where we have same for each project, and additional steps are added based on the project needs. So basically the root is the same, and then we can see the differences, let's say, at the end of the pipeline configuration. And the same goes for the application. So we're installing the applications inside the cluster, usually in the same way, also tweaking on needs of the project. The second thing is the Terraform. So each project, we have the Terraform structure where we create our backend services, main services, and we get the outputs to the Terraform, and those outputs goes to the shared modules that we created across our different projects. So we have the same objects for each project and specified variables for the infrastructure. Or let's say for Project Alpha, we would like to have Kubernetes in version A and version B for different projects. So those are those variables. So those are the distinction between the different projects. And also, we thought about, okay, what if the project doesn't want our common modules? Maybe there required some modules that we does not have. For example, I don't know, we didn't see Azure Function, for example. Maybe there is a project that requires that. We can either incorporate into our, let's say, portfolio, so our modules, or we can create from the scratch in the projects because we think that, okay, this is function that probably will not be shared between projects, so we will create for you, and that's it. So then, having that structure, if somebody goes into the project, we'll see, okay, those are the pipelines, those are the infrastructure, and those are the specific modules, so specific configuration for the infrastructure. And that's the infrastructure repository. Now, if we go to the GitOps repository, so the applications, we try to have the similar structure. So we have the Argo CD, where we install the Argo CD using, I think it's called App of Apps. So we're installing the Argo CD and configure the Argo CD in such way that it looks into the repository itself, scans for any application that comes into the repository. So basically, that's the GitOps approach. So we are configuring the infrastructure from the Git itself. So any configuration we put into the main branch in the repository should be, at least, I think, in 5 minutes in the infrastructure. And to do that, we configured Argo. Okay, install itself and look what applications you have. And we do it in the applications. So this is the common part for each of our projects. So we are installing Argo CD, and then we define the applications pattern. Basically, it's the Helm chart again, to fit Argo CD configuration with those applications. And then there are the manifests of the applications for the project. So basically, this is what differs in different projects, because different projects got different applications. Basically, we don't want to create application manifest and then configure, okay, let's configure this on that environment. Nope. What we do, we are creating the folder, and basically Argo CD then scans it and deploy according to the configuration. And what you can see here on the green, usually we have two things into our templates. So we have the templates of how our application should look like. We have values that we apply for all our environments. And there is the values folder with the name of the environment. It means that this is only environment-related configuration. The simplest configuration, ingress, and different URLs for your production and for your development environments. So basically, you cannot create the same URL for both. So basically, on the development, there will be different URL than to the production. So basically, this is the things that differs. The other configuration, I don't know. The image and the resource usage, the configuration, the environments, whatever you name it, is the same. The only thing will differs will be the URL. So most of the application config will be in the values, and then this URL will be separated values for this particular configuration. And what is our current project workflow? Right now, it looks like this. We have separate repository for our modules in Terraform. We have separate repository for our projects and DevOps applications that we, let's name it Grafana and Prometheus. And then if we spin off the project, basically we create the infrastructure repository for this project and applications repository to know the applications. And then when we're creating the infrastructure, basically we're using the same code from infrastructure repository to reproduce the environments. And then we configure Argo CD, also one for all environments, to configure all of them at once. Of course, the configuration for the development will be different than in production, because in GitOps approach, everything what is in the code is on the environment. So if we create something, we create on the environment. If we delete something, it will be deleted. But in production, we need to push the button that, yes, we want to delete it. So that's the security, what we have. So basically, we are responsible for top 3 repositories, and basically, those 2 are shared between each of the project. So coming back to our first 2 projects, basically what we are having right now, we are having shared modules and shared applications across all our projects. And then we create separate repositories for each of the project. So basically for project alpha, we create 2 repositories, applications and infrastructure. The same goes for the beta project. So basically we are creating 2 repositories, and then within those repositories we are configuring, okay, on the alpha we want 4 environments, on the beta we want 3 environments, and those are the configuration differences. And now we are a little bit better with configuring our environments. And what is for the future? So, of course, it's the living project, and it's not written in stone. If we see some obstacles, we try to resolve them and add additional functionality. So what we are trying to do is, inside KMD, try to move as many projects as we could internal to this GitOps approach. We want to automate the project setup deployment, because there are still some manual things to do, but we would like to have it as automated as we could. Right now, what we are having, because more and more projects, more and more environments are using our templates or blueprints, and we would like to have better management between different environments. So that's what, for example, what I'm working right now. And what we would like to do is to enhance our user experience, especially from our team perspective, because somebody is joining our team and we would like to have a seamless experience to join in our infrastructure as possible. So that's for the future. And now, according to, I have 20 seconds for the QA, so.
Use it wisely. Any questions from the room? Okay.
All right, so as HashiCorp is trying to push Terraform out of the OpenStack, do you have any plans of moving out somewhere else?
Of OpenStack?
Yes, because it's trying to commercialize the Terraform.
But we are not using the OpenStack for that. And basically what things about the licensing I heard regarding the HashiCorp and Terraform is that they would like to have the license to not reuse their code to build another applications. So for example, I'm using Terraform to build application, let's say it KMD infrastructure perfection, and sell it to anybody using this one. So this will be prohibited. But inside, if you are using the Terraform and we are telling we are using the Terraform to create infrastructure, that still should be open source and free to use.